All right, let's get going once again. Um, so we have been talking about the cards rule. Okay, so I want to continue from there. I'm going to share my screen. If you could see my screen. Okay, let me know if you cannot see my screen, but I'm assuming you guys are able to, and then keep going. So we were talking about the cards rule. Um, there are about 13 cards rules starting from rule 0 to rule 12, and it's called the 12 rules of card. As I said, Boyce Card was the father of DBMS, and he created certain rules for the database to be in relational form. Okay, if you want to call a relational DBMS, then it has to satisfy certain rules. Okay, just before I go in there, I slightly want to make you understand that we have been talking about all these concepts. How are we going to apply those concepts are this? Um, when you're going to go start a new business or somebody starting a new business, you go work for them, for example. If you happen to be a database designer, they're going to ask you to design a database. So for you to design a database, you cannot just basically say, okay, let's start storing every data in terms of rows and columns. You cannot do that, right? You have to apply all these rules. That is where you're going to realize and appreciate, oh, this is where MarieDass taught me all these, and this is where I'm applying all this. Okay. So all these rules are applied when you're creating new database. Okay. So one of it is cards rule. You have to make sure the cards rules are satisfied when you create your database. Usually when before you go into database, there is a description given. You read the description. Okay, that was my mistake. Okay, thanks. All right, and I am still sharing my screen. Okay, so that's where you're gonna appreciate and apply your cards rule and appreciate that we are doing good. Um, so certain rules we looked at in the last session. So one of it we're gonna quickly brush ourselves. Rule 0 states that everything should be for everything to be for the system to be qualified for a DBMS. For example, you're going to design something, you could define or design them in hierarchical model or network model. But if you want to go into a relational RDBMS model, you want to make sure that the system to qualify for an RDBMS, it must be able to manage the database entirely through relational capabilities. What are the relational capabilities? We have seen a lot of things, and we will be seeing certain items for it to be relational in nature. What else should be satisfied? And then every data about data, basically metadata, should also follow the same rules of RDBMS. So what you're going to store is basically data, and then internally the catalog maintains internal metadata. Um, that should also be stored in terms of rows and columns. Okay. Guaranteed access means that so the rule 1 is very important. Okay, please understand. We've been talking about it. Everything should be stored in terms of every data should be possible to be stored in a cell. Okay, when you looked at, I showed you a table. In a table, you have rows and columns. Each column of a row is called a cell. Okay, so you are storing data in a cell. So you must be able to store data in a cell. Okay, and followed to that or associated to that is the next rule that says anything that I store must be able to be precisely accessed by saying that a primary key, a row, and a column. If I give you these three, you should be able to point to that specific record. So to repeat, if I give you the table name, for example, the student table, and if I give you the student ID, which is a row or primary key, let's say student ID S001. And if I tell you the column name, excuse me, date of birth, so you go to this table, student table, you go to row number S001, and then you go through the columns and then go to your database, get that data, right? So there is a guaranteed access to every atomic piece of data. Atomic piece, what I mean by each cell, okay? Make sense? All right, number four, treatment of null. I know we talked about it. You should be able to handle null efficiently. Null is basically absence of data. Okay, I always prefer using this. People say nothing, people say null, I mean, people say space, zero. No, space and zero are not null. To me, null is absence of a value. Okay, so any operation on null turns out to be null. Okay, all right, that's where we stopped earlier, so I was rushing. So now, active online catalog, rule number four. This is again nothing but we have something called data dictionary or a data catalog, more like a data about data internally, more like a metadata. So what it says is even the metadata should be governed by the same rules of the actual table. If an actual table, I say, um, if in an actual table I have certain rules, then the same rule should apply to my catalog as well, database catalog. Make sense? It's a little theoretical, but what I'm trying to make you understand is certain key points if you want to note down, as we go through, so that it's easy for you. Okay. Um, then, and again, in the exams, I think there may be some questions about um, Cod's rule, but you're not going to explain or write all these 13 rules. I would say hardly if you remember five or six, very important ones. That's are easy to. Okay. So now what I'm going to talk, some of them are important now. Powerful language. So for you to access, um, am I muted? What's going on? No, I don't think I'm muted. You guys hear me? Somebody's saying I am muted. You guys hear me? Okay. All right, powerful language. So we're going to talk about SQL. So this is again very important. We have a separate chapter on SQL. We'll talk about it as we go down the line. Um, like I said, you have your DBMS. Okay, the DBMS, there has to be somebody talking to the DBMS. Yes. Who does the talking? If you remember, we talked about three levels of architecture. Three layers of architecture. We have the database layer where your database resides, and then you have an application layer, and the application interacting with the database and the end user, right? So neither me nor the end user nor the database designer can talk without a language. So that language is called SQL. SQL stands for Structured Query Language. So there is a structure in which you write a query, and the query talks to your database and then gets the data back for you. Okay, more like we do your JavaScripting or Java, programming languages. So there must be a well-defined query language that can powerfully talk to DBMS. Believe me, SQL is very tricky. We always think, SQL is very simple, but it can really do a lot of things. There are certain things that you need to know. In the places that I worked, query tuning is very powerful. People always talk about query tuning because I can write something in different ways. Okay, the way we'll talk, right? Everybody talks in different style. I talk in my own style, you guys talk in your own style, but the message could be the same. Yes. So same way, um, you know, it has to be powerful, meaning there are certain speakers, some motivational speakers you might use. They're very powerful. When they even talk one line, it's very powerful. They carry a lot of message. So same way when you write your SQL, it has to be well tuned, meaning how is it fetching data, how quick it's fetching data, and how much of resource it's using. Please understand this. This is what is query tuning. You'll hear this term a lot of times, and it's one of the basic questions you go for any interviews. Any interview, they always talk about how do you fine tune your query? Have you done query tuning? What it means is, you might always say, when I do a select on a table, it's getting me the answer. What are your problem? Like I said, writing 100 if statements instead of using a switch statement or an evaluate statement or a while statement, right? So at the back end, the user does not know what language was used, how was it written. I don't care whether you use 100 if statements, whether you used a switch statement. Nobody cares as long as the user gets his data. But for the system, it's very important, right? As a professional, it's important for you because you know the basics behind it, behind the computers, behind your computer architecture. You should know that you're writing your query in an efficient way. Okay. See, a lot of times we apply a condition, select the data from the table. After you select the data from the table, then you apply some condition, right? A lot of times, while selecting itself, you need to do a certain criteria that you select only specific data. We'll talk more about it. I don't want to deep dive too much, but what I want you to understand is the SQL is very powerful. Plus, it's in the hands of the user. We always say, right? A bad carpenter blames his tools. So it's always in the hands of the person using it. So you have to write a very powerful query using that language. Okay. So every DBMS must be accessed by a powerful language. Now, updation rule. Updation basically means update. That's the verb, right? Update means you can update the data in the table. For example, if you're storing, for example, you're storing the data of date of birth or age. Okay, as the age keeps upgrading, we usually don't store age. It's a derived data, we say, because it can be derived, as I said, from a date of birth. Excuse me. Certain data keeps changing. Like for example, your bank balance. As you go withdraw from your bank balance changes. So those are fields that keep changing. So anything that's theoretically updatable must also be practically updatable, if I can use the term. Okay, that's what the view updation rule says. If you're telling me if I withdraw $100 from the bank, my bank balance should go down by $100, that's theoretically I'm saying. Practically, I should be able to do that using my SQL in my table. Simple. That's what is a view updation rule. Next, relational level operation. So apart from you know update, there are certain other things that you can do on the table. Insert. What's an insert? Inserting a new record. Okay. For example, we have a college database. A new student joins the college. We want to insert the record. Delete. Probably when somebody leaves, we don't want to store the record. We delete. Update. Okay. Usually the data is not deleted from the database. It's usually marked inactive. Okay. Remember that. In a practical environment, if you happen to do that, remember this piece of advice: never delete the data from a table. Certain people have done this in my projects, but never do that. When somebody is meaning delete the data, there is something called soft delete. There's a hard delete and a soft delete. Hard delete means you totally take the record out of the table. Soft delete basically means you mark the table as inactive. You have a column to say is the table active or inactive. You mark the table as inactive. For example, a customer. If you go to a bank that you have an account, you cancel the account, they don't take away all your data. They just mark you inactive customer, so that tomorrow if you come back for certain things, they can still fetch your data. Okay, so don't do a hard delete anytime. Update operations, as we talked about updating the data. So all these are relational operations. These all should be possible. There is a separate topic about relational algebra here. I'm planning to leave that for your self-study. It's not really too much. I know you have the set theory, so the relational algebra concepts. So we'll talk more about it as we go down. Very important, physical data independence. We talked about this, data independence. Anybody quickly want to say what is physical data independence? Just the keyword that I used when I talked about data independence. I talked about physical data independence and logical data independence. For physical data independence, I used only one word. And for logical, I used another word. Does anybody remember what is it? Physical data independence is where. Okay, I use the term where. Physical means where address. Okay, where is my data stored? Data independence meaning I don't care. Independence means I don't care. I get freedom. So I don't care where the data is stored, whether in a file or in a table, or a file and a table. Some of it in a file, some of it in a table, I don't care. But as long as I get what I want, I'm fine. So that's physical data independence. So for your table to be in RDBMS or relational in nature, it has to satisfy physical data independence. Your DBMS cannot say, your DBMS system cannot say, if the table is stored only in a table, I'll work. If the table is stored only in a file, I will work. No, that's not true. Because remember I said, even the data in your tables are internally stored as files. Please remember, though we talked about the disadvantages of file system, the data in your tables are internally stored in files, a file system. Just the DBMS is your representation. The data is represented in rows and columns, nicely like a table, to you, it looks like as if it's stored as a table somewhere, but it's not. To you, it's presented like a table, okay? Now, logical data independence, again, I use the term, um, how is the data stored, meaning the structure of the table. Which column is stored first, which column is stored next, I don't care as long as I get what I want. Okay, we'll talk about um, all these things in our ER diagram. Okay, we have something called entity relationship diagram that we're going to talk very soon. When I go there, I'll talk about logical data independence. But in short, logical data independence says, I don't care how the data is stored as long as I get what I want. Yes? You guys with me so far? All right. Integrity. Believe me, this is a very important word that you have to remember in DBMS. As you keep going through in your DBMS, this is a term that you can never live without it. Integrity. Integrity means um, maintaining something in order. If you go by the definition of integrity, maintaining something in order. Okay. Integrity, independence. So let's talk a couple of things around integrity, and then I'll go into it. Certain rules have to be satisfied in DBMS. Okay. If you guys remember, we talked about the files. I'm going to bring up the marks file here. Okay, if you remember the first day, I had a file system where I said, okay, this is my marks file. Um, let me share my screen. New share. Okay. All right. So here, so this is my marks file. Okay. Does anybody remember what is the parent table I used? We talked about parent table, child table. I used a parent table. Do you guys remember what is the name of the parent table? Are you guys sleeping? Yes. Somebody said yes here. No, I'm kidding. All right. So this is the student table that I used first. Okay. So this student table has all the student data. Okay. If you want to scroll down like this. So this is the first file, base file, the student file that I used to store the student information. Okay. And then I went into the other file, which is the marks file. Yes. So now in this file system, I can go enter marks of some, for example, I saw somebody new today here. I can start entering the marks here, right? Like this. It allows me to enter the data here in the marks table without me worrying about having to enter data in the student information table. Yes. So this is basically a child table to the student table. This is the marks table. So without a student present in the student table, which is my master file, this file is allowing me to enter data into the child table. What it means is this child record is existing without a parent. Not possible. Neither in DBMS, not in practical life, not in biological life. Yes, there cannot be a child without a parent. So your DBMS should not allow that, whereas your file system allows it. So that's what we mean by integrity. So one of the integrities here is that you cannot have a child record without entering that record in the parent table. I'm going to stop here for a quick second to understand Do you guys understand this point? This is very, very important. I will be building on this a little bit as we go down, like primary key and foreign key. So I want you to understand. And if anybody doesn't understand, please feel free to stop. You know, you can ping me separately. And this is another thing I wanted to say. So if some of you might feel, I understand it's kind of a mixed, people I have here. Some of you are know DBMS. Some of you know more than what I know. Some of you may not know. Some of you know nothing about DBMS. So it's a mixed crowd. So if you think you don't want to ask questions just because others know, I don't want to be embarrassed by asking, ping me privately. I can spend a few minutes more. I can spend some time with folks who really need that, kind of help to go a little bit more in detail. I'm trying to touch upon certain things. My interest is, like I said, my primary interest is to make you understand DBMS. That's my primary interest, and to create some interest. I always say, I want to put a seed in your mind or in your heart and soul to about DBMS, and just put a seed in the soil so you guys, kind of germinate, grow into a plant of DBMS. So one fine day, if you guys turn out to be a DB designers, database designers, happen to be your database administrator, I'll take pride in that, saying that I have some role in it, right? you know so, but if some of you want to connect with me outside of this and say, look, can you spend some more time to explain more in detail, I don't understand this, I will certainly be happy to do that. Okay, so don't feel bad if you don't understand, feel free to ask. Okay, so getting back, integrity, that's one of the integrity. So I cannot have a record or an instance in a child table without having a corresponding record in the primary parent table. Make sense? That's one of the integrity. Certain other integrities are primary keys. Primary key has to be unique. I cannot have two people having the same student number. Not possible. Okay, the primary key, the student number has to be unique. Okay, we have something called check constraints. I'll talk more in SQL. Check constraints are basically meaning certain things have to be checked before the data can go into the table. For example, if I'm entering the marks, the value of the mark has to be anywhere between 0 to 100. Assuming 100 is the maximum, 0 is the minimum, I cannot enter a negative value. I cannot enter more than 100. So I'm limiting the value. I'm putting a check constraint to say, before the data is entered, can you please make sure the data is in this range? Check the domain of this value. Okay, that's a check constraint. So these are certain integrities. Okay, so yeah, DBMS should be able to allow you to do all these. Okay, and then should be able to enforce that integrity on the table. Any DBMS that you use, DB2, Oracle, anything that you use should be able to enforce these constraints. Okay, these are like the skeleton. Now, distribution independence. As the name says, distribution, it means it's a distributed database. Okay, the distribution means distributed. What is distributed means, this is again another term you'll keep hearing as we go. Distributed means your table is distributed on a network. Okay, this is after the distributed database has come into existence. This has really helped all these the world of internets. What it means is this: you have an account in the bank, like I explained earlier. You're able to access your bank irrespective of wherever you are. That's because the database is centralized. Centralized meaning it's at one place and it's connected by the internet or the network to the database. From wherever you are, you can connect using an internet connection to that server, to where the database is set up, right? So it means different networks connect you to the database, okay? As well as all my data need not be on one database. It could be sitting on 5 different databases, and 5 different databases could sit on 5 different servers, and all these 5 servers are connected. So if I'm talking about, okay, today I log in, I want to understand what is my details about my savings account, I might query the database or the user interface or the ATM to say what's my bank balance, What's my savings account balance? It will go hit one server. But whereas I might have a loan account, I might have taken a loan with the bank. So now I go and say, can I check my loan account, loan balance? That details may be stored on a separate database on a separate server, right? But still, I can do both at the same time because they are distributed on two different databases or data servers, but still they are connected. I'm sure you have a topic on networks. So networks will talk about how these are interconnected to each other. Okay, these are more like the cobweb, right? That's where the web came from. You know the spider web? That's how they're all connected. Every server is connected. So distribution independence says, irrespective of how my servers and my database are distributed on different servers, still I should be able to get the data that I want. The primary intent here is to get your data. Yes, to get your money from the bank is your intent. You put your money, hard-earned money, you want your money back, as simple as that. So that's your data. As long as you can access your data, you can get your data, you're all good. Okay. Now, two more rules. Raise your hands if you want me to stop. Number 12. Non-subversion rule. The moment you look at this heading, some of you would have gone away from here, right? Never mind. So non-subversion, meaning subvert, if I can use instead a term called bypass, okay? Now, a lot of times in practical environments, we can bypass certain policies, right? You go into an organization, they might have set certain rules. Okay, if you come here, these are the rules that you have to follow. For example, you go to a hospital, you have to walk into the hospital, register yourself in the in the entrance, in the reception. You enter into the lobby, register yourself, you wait, and then you're given something to fill up. You fill up, then you're waiting. Somebody comes pick you up for maybe for the vitals checkup. Vitals meaning your temperature check, whatever it is. By the time you go meet your doctor for what you came to the hospital, it might be another 2 hours. Yes, but assume you know the doctor. Doctor is your personal friend or a family friend. You don't do all these, right? You walk into the hospital, you just say, I'm here to meet this doctor. Just tell him I'm here, and then you get a special treatment, right? You bypass all this process. You directly go meet the doctor. Yes, and this happens not only in the hospitals. I mean, in many other places. Like for example, you go into a government organization, as assume where your relatives work. You bypass all the system. You can go directly meet people. So that's basically what you mean by subvert. But what DBMS says is, I can access my data primarily via three ways. What are the three ways I can reach my data? Anybody? I guess still up. What are the three ways I can access my data? Three people who can access my data. Today it sounds a little quiet. What's happening, guys? Monday? Is it a dry Monday? Monday is always hard. People don't want Mondays. The statistics says Monday is a day that people have a lot of stress and don't want to come to work. So I don't know if you guys are very quiet. Usually I hear a lot of pings on the chat, people interacting. Today seem to be a little quiet. Anything bothering, let me know. We can talk outside of the subject. I'm sure, we can do that. Or I'm worried you guys are not with me. Am I having all of you with me? Yes? Can somebody tell me yes? Check the mute off and say, yes, I'm with you.
Yeah, sir.
Perfect. Thanks, Gahan. I think it's Gahan. Thank you. Okay. No, so that's a non-subversion rule. So the non-subvert. So subvert means bypassing. So the non-subversion rule says there are three people primarily accessing the database, right? One is a presentation layer. Presentation layer is nothing but the end user. So we talked about this in our architecture, right? The three-tier architecture says there is a presentation layer, your user interface, your ATM. I keep using one example so it's easy for you to remember. So the ATM screen, the ATM screen is the one. The presentation layer is one which talks to the database to get the data for you, right? So if you are going to ask, what's my bank balance? Your ATM is an user interface, goes to the presentation layer, sorry, application layer, gets the data from the DBMS. Number two, the application layer are nothing but application programmers. If you happen to be an application programmer, you can write a COBOL program, you can write a Java, C, C++, whatever. You can write a program to say, go hit this database, get the data for me. Possible. Okay. Number three, that sitting on the DBMS layer itself, like for example, the DBAs, you can write a query, SQL query, not an application program. You see the difference? The application program is basically you're writing a Java program or something, which in turn invokes the table. But whereas your SQL straight hits your table. Okay, your SQL raw hits your table, raw talks to your table. So these are the three different people. So if somebody has access to a lower layer, for example, I am the end user. Okay, for example, I work in X bank. Okay, I can see my bank balance through the ATM. Because I work in the bank, I can also go to my log into my system, the bank system, and check my bank balance. I may be an application developer. I know how to access the tables. I can go write a query to get the data from the table. But that does not mean it gives me access to do something outside of the RDBMS rules. So the RDBMS rules cannot be bypassed irrespective of somebody having an access to a lower level of data. Did I make it clear now? Whether I have access to the UI, whether I have access to the application program, or I have access to the table, never mind, still all the rules of the DBMS must be satisfied. Because I have access to internal layer does not mean I can bypass those rules. Okay, that's non-subversion. I think we are done with those CORDS rule. So I'm going to request you guys to go through it, go through all those 13 rules. It's called CORDS 12 rules, but there are 13 rules. Go through it. I'm expecting that I made it clear almost all of it. So if something is not clear, come back with questions on the next session. But please remember this. This is going to be some exam questions, and there are going to be some questions for you. Like I said, our interest is also on the marks, okay? Because we study for marks as well. Okay, that's the gateway. Okay, all right. With that being said, looks like we have another 6 minutes, but I would like to go a little bit beyond. So if we get disconnected, please join back in the same link. We'll go a little bit further, okay? With that being said, let's keep going. So before I continue, I just want to go into talking about different types of keys. Let's see what keys you guys remember. I want new people to open up and speak. Um, you know, what are the key fields that you have heard of? Have you heard of key fields? What are the different types of keys that you have heard of? I just see I've lost some of the people. Looks like there are only 12 compared to what I had before. So if somebody is not knowing where to connect, please let them know. I'm going to use the same link every time if you get disconnected. So join back in the same link. So let them know if somebody is missing here. Okay, so I want to talk a little bit about different types of keys. Okay, I'm sure you guys might know about it. If not, let's talk about this. Number one, so key fields. We're going to talk about key fields in DBMS. There are a lot of key fields in DBMS. I'm going to talk about all these. Number one is candidate key. What is a candidate key? Okay, I usually use this term. The candidate, the term very much aligns with, we use in the political field, right? People who are contesting for an election are called candidates. Yes. For example, whether it's an MLA, MP election, or is in a minister's election, chief minister, prime minister, each of them is called a candidate. We usually say this person is, like, for example, is a prime minister candidate, meaning he's contesting for a candidate. I mean, for that role, for that prime minister role, or for a chief minister role. So you guys might know there are multiple people who are contesting in the election to become chief minister. What it means, they assume or they qualify. Let me use this term, qualify. They qualify to be the chief minister, and they contest in the elections, right? Assume there are 5 different parties. Each party has their own candidate for chief minister. So each party feels that this one person from their party can do the job of representing the state, and they think that that one person can be the primary chief minister candidate. Yes, but does all those five, assuming five different parties are here, each party has one candidate, does all five person end up to be the chief minister? No, only one person end up to be the chief minister. Yes. So same way here, each of them is called a candidate, and the one who gets elected finally is called the chief minister. Yes. So same way here, in a table, there are different fields that can become, that are eligible to become a primary key, but only one of them becomes a primary key. If you ask me what it means, I'm going to go back to the table we used. If you look at here, I can actually point to a record using student number. If you give me the student number, for example, S006, for example, let's use this name. I never use this name, I think. So S006 represents all the details about the student called Pranati. So if you give me student number 6, S006, I can, or the DBMS can precisely go point to this record and say this is student number S006. The student name is Pranati, gender is female, date of birth is this, average marks is this, grade is this. Okay. Also, I can use name. Name, assuming not two people have the same name. If I use the first name and last name, or the name and father's name together, assuming I have father's name stored here, if I give the name and father's name, if I say Pranati, daughter of so and so, that also can take me to this record precisely. Or if you give me date of birth, can you get me the record whose date of birth is this? Assuming every person has an unique date of birth, I can precisely get this record. Yes, there may be other fields like address. If I give the address, assuming everybody has unique address, not two people live in the same address, unless you're related. If I give the address, you can go point to this particular record precisely. Yes. So each of them is called a candidate key. Student number is a candidate key. Name along with father's name is a candidate key. Date of birth is a candidate key. Address is a candidate key. But I choose only one of them. I don't choose more than one. Which one do I choose? The one that's easy to handle. If I choose address as my primary key, it's going to be difficult. Every time I say, I have to say, if I have to point to Pranati, I have to give the whole address. The address might be like 200 characters long, right? I have to say the door number, flat number, maybe the street number, floor, etc., 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 which is complicated. Rather, if I just use the student number S006, it's easy for me. So I'll tell the SQL, go get me the record whose student number is S006, rather than saying, go get me the record whose address is so big. Make sense? So we will choose the one that's very easy to use in our querying. So from all of the qualifying candidates, you choose one of them and that one becomes the primary key. Okay, so clear? So the primary key is nothing but that uniquely identifies a record of a table. As simple as that. There may be questions in the exam about define primary key. What is primary key? So a primary key precisely defines a single record of a table uniquely. You have to use the term uniquely. Uniquely means, we talked about candidate key. The keys that are eligible to become primary key are called candidate keys. Primary key, again, is something that can uniquely identify a single row. If I know the primary key, I should be able to point to a specific record. Is that clear? If it's not, please let me know. All right, and then we talked about, we're going to talk about alternate key. What is alternate key? After, for example, there were 5 candidate keys. You choose one of them as primary key. Rest of them are called alternate keys. What is an alternate key? Basically meaning when the primary key, if the primary key was not chosen to be the primary key, others could have been chosen as primary key. Yes. So alternate key is nothing but candidate key minus your primary key. Okay, so alternate key can also uniquely identify a record, meaning alternate key has all the qualities and features of primary key, but it is not the primary key. Simple. Like I said, there are 5 people who qualified to be a chief minister. Only one of them was chosen. Rest 4 of them qualified, but are not the chief ministers. Okay, so that's about alternate key. What is super key? This terminology is not used anywhere practically, but there is a terminology in your DBMS, so I just talk about it. Super key is nothing but a primary key plus another key. Okay. For example, if I tell you, can you get me the details of um, student number? For example, it happened to be so. I use the example of Pranati, and Pranati spoke up and asked a question. I appreciate that. So I use this example today. So I had this student number S006. Uh, or probably this is an idea for me. I should keep using different names, and then different people can speak up. I don't know if that was a trigger, so I should switch. I should change examples every day. So if I can go back, use the same table. If I give you this student number, for example, I'm going to use Shashank today. So if you give the student number S011 Shashank, instead of giving only the primary key value, instead of, see, if I tell you, can you go get me the records of student number 11, you can very well go get me this record, because you know there'll be only one record with student number, give me a quick second. Yes, so student number 011, you can very well go get me the details. But if I also tell you, go to the classroom or go to the table, get me the student whose student number is S011 and whose name is Shashank, well and fine. I'll go to the table, I get the record, but the name was an additional information. Yes, you gave me the primary key. You also gave me an additional information, additional attribute, additional column, which was not necessary, but it doesn't do any harm to me. Okay, so that is called super key. Super key means an attribute along with a primary key will constitute a super key. So in this case, student number and student name together form super key. It's just like superstar. I don't know if they have some special qualities. No, but in DBMS, nothing special. Okay, super key is never used. So far in my lifetime, that I said, we have never used super key. Okay, now then I want to talk about foreign key. If I'm not right, I'm going to talk about what else I have. Just want to make sure I don't miss anything. Yes. So let's talk about foreign key and a composite key. Okay, what is a foreign key? I generally define it like this. Who is called a foreigner? You know, we use this term foreigner, right? Who is a foreigner? Anybody who is in a country other than their primary country is called a foreigner, right? So somebody who leaves their primary country, comes to a different country, they're called foreigners. If you travel to a different country, you become the foreigner. If somebody else from a different country come to your country, they become foreigner, right? So put in simple terms, if somebody present in a different country, if a citizen of the primary person of one country stays in another country, they become foreigners, right? Same way, foreign key is nothing but a primary key of one table which is present in another table is called a foreign key. Make sense? A primary key of one table present in another table is called a foreign key. I'm trying to use this example here. Okay, so if you could look at my example here, so I have um, 2 tables. Okay, I have a course table. What I'm storing here is the course name or the course ID and the course name. For example, if I say course ID C001, I mean I'm pointing to maths. If I'm talking about C002, that means it's physics. So there's a course table where I assign a course ID for each course. For math, I assign a course ID, physics, I assign a course, because I might be having 1,000 courses in my university. So I'm storing a course ID for each of the course. So anytime I want to point to a course, I can use the course ID rather than the course name. It's easier. Sometimes the course IDs are very big, digital signal processing. I don't want to say that. Instead, I say course ID C009, right? So I have a course table and I have a marks table. I store the marks of each student for each course. So this will be my table. I have a student ID S001 whose core for the first course. Let's assume this student S001 has joined in two courses. So for his first course, C001 maths, his mark is 100 and his grade is A plus. So this is my marks table. So here I have to store the student ID and the course ID to store the marks. Yes, I cannot just not have this and just put course number. Yeah, I cannot just have the course number, course name and marks, because if I tell you this is the course number and these are marks, the next question will be whose marks is this? I understand it's a marks of the subject math, but who's but for whom? Which person? Bharat, Manjushri, whose mark is this? So that's why I need to have the student name as well. So I'm storing the student ID, course ID, the course name, and the marks. Yes. Now listen carefully. In this course table, what is the primary key here? Course ID. Yes, because given course ID, I can uniquely find a record. Well and fine. Now in the marks table, what is the primary key? Let's see if you guys are up and listening. What is the primary key of the marks table? Remember, the intent of marks table is to store the marks and retrieve the marks. Always store and retrieve. That's the intent. Yes, why do we have tables? To store and retrieve the data. So I stored the marks. I want the marks. Okay, now my question is primary key. What is the primary key of the marks table? Remember my definition. Marks table, the intent of primary key is to fetch one record uniquely. One record uniquely, meaning if I give you the primary key, you should give me only one record. Don't give me saying, you told me this primary key, they gave me 10 records. That means your primary key is the primary key. Okay. So I'm asking a question to you guys. What is the primary key here for the marks table? I give 10 seconds for my answers. No answer says we are not listening. You can also say we are thinking. Okay, that's also an answer to me. I don't mind. No answer is a bad answer. I always say that, right? If you are thinking, saying, I'm still thinking, I don't know, I agree. I take that answer as well. Okay, so here in the marks table, for me to specifically identify a record. So I had an answer here. Somebody said course ID. Okay, very good answer, but wrong answer. That's okay. Uh, so course ID cannot be a primary key because, for example, like I explained, if I just give you the course ID, your next question will become, I go into the table. For example, I'm storing details of 3 students here. Yes, 001, 002, and 003. There are details of 3 people here. Okay, I'm storing the marks of the first student, the second student, 2 records point to the second student, and 1 record point to the third student. Now, my question was to find the marks of somebody. If I use only the student ID, S001, if I tell the DBMS, go get me a record from the marks table whose student ID is S001, let's assume you are the DBMS, I'm sending you, let me use Alok as an example here. I'm sending Alok. Alok, go to this table, get me records whose student ID is S001. How many records, Alok, will you come back with? If you go into this table, how many records do you find with that record S001? In this marks table, if I send you with the student ID S001, you go to this table, if you're trying to get a record, how many records do you find for student S001? You find 2 records there. Yes, thank you. Somebody responded here. So we got 2 records. What is my rule for primary key? I said I should be able to uniquely identify. Uniquely means only one record should come out. So that means my student ID cannot be the key field. Okay, I'm going to slightly change this, assuming I'm storing this, the marks of maths and physics here only. So I have, for student number 1, I'm storing maths and physics mark. For student number 2, again, I'm storing maths and physics mark here. Now this time I'm sending, let's assume I send Krishna now. So I'm giving Krishna the course ID. I'm sending Krishna saying, Krishna, go to this table, marks table, get me the details of the marks, or the records that have course ID C001. Now Krishna goes to this table. How many records do you find, Krishna, here? If you go to the marks table, so Krishna says, I'll come back with 2 records. Again, it's not good. My intent was, if I give you the primary key, you should come back with only 1 record. So that means neither the student ID nor the course ID could be my primary key. Make sense? So here, then what could be the primary key? Now I'm going to send, who else do I have here? So I'm going to send somebody else, okay, to go find, let's send Gahan this time. So Gahan, I'm going to send you to say, what do you need if you have to fetch 1 record from this table? My intent is to find the marks of somebody for a particular course. So if I have to send you, what are the details you're going to ask me? You have to ask me the details so I can find 1 record uniquely. So now Gahan gave me an answer, C005. Now let's make Gahan more complicated. I'm going to store now student 002 again has the same subject passed. Let's say student is also enrolled in biology. Okay. And now what happens? Now again, if you go with, if you're asking me, so you, when you talk to me in terms of the column name. Instead of giving me the value of the column, let's talk in terms of the attribute name or the column name. So what column name do you need, or what value for the column name do you need? So you said course ID. Again, it will not help me because there may be 2 people who are enrolled in biology and I'm showing the marks. So now this becomes complicated. So I need 2 things here. I have to tell Gahan, I need the marks of the biology subject or the course C005 for the student S002. Make sense? So I have to give you 2 information. I have to tell you, I need the marks of a particular subject of a particular student. Make sense? If I give you this, for me to uniquely identify 1 record, I need to give you the student ID plus the course ID. If I tell you the student ID is S002 and the course ID is C005, there will be only 1 record. There will be 1 student S002 who is enrolled in biology only once. Yes, the same student will not be here for the same subject again. I'm going to slow down. So a student will enroll in a subject or a course only once. Yes, but the same student can enroll in another subject. So the student ID will be duplicated. The student ID 001 is present 2 times, 2 is present 3 times, student ID 3 is present 1 time. But for a particular course, his entry is only once. Student 1 will have only 1 time enrolled in the course 1. Student 1 will be enrolled in course 2 only once. So for you to fetch a record uniquely from this table, I have to give you both student ID and the course ID. This is called the primary key now. Excuse me. So what is the primary key of the table here? Both the student ID and the course ID. Make sense? Here the student ID is both student ID, sorry, the primary key is both student ID and course ID. So how many primary keys do I have for this table now? Let's see. What do you guys come back with? How many primary keys do I have for this table? How many primary keys? Anybody? Others? Go over then. How many primary keys? Do we have two primary keys for the table? Because we talked about two columns? No, because any table can have only one primary key. Okay, that's a standard rule. Every table will have only one primary key. So, but I talked about two columns. So that is where I use the term composite primary key. You know, in English, we use the term, right? Compound sentence, all right? Composite means made of multiple parts. Okay, thanks. We got so many responses. Everybody said, I was expecting to some of you to say, we have two primary keys, but good. Everybody said there's only one primary key. But it's called a composite key or a composite primary key. Okay, makes sense? So this is a composite key, meaning a primary key made of multiple attributes. So for me to identify a unique record, I'm using two attributes, student ID plus course ID. So it's called composite ID, composite key. Because it's a primary key, I call composite primary key. Make sense? I will just quickly finish off with only one more item, foreign key. So foreign key, what it means, if you see here, course ID is part of the primary key here, yes? But whereas, sorry, in this table, course table. So in the course table, course ID is my primary key. Yes, full complete primary key, standalone primary key. But when it goes to the marks table, it is not the primary key. You can argue that it's part of the primary key. Yes, it is, but it is not the primary key. Okay, my rule is it is not the primary key. Now course table traveling to the other table, marks table, becomes the foreign key. So I am a king here. I am the primary key here in this my table. When I go to a different table, I become a primary foreign key. Okay, so I have more examples I can talk. Let me quickly go down a little bit. For example, I have a table here. We'll talk about this tomorrow. I have a marks table. I'm storing the student number, store a course ID and a marks, and I have a separate table for grade. So again in this example, in this is a second table. Here, this marks is my primary key. Marks is my primary key because if I give you the mark, you can identify a record. So in this table, marks is my primary key, but here in this table is a foreign key. So in simple terms, a foreign key is nothing but primary key of another table. Okay, with that, I will stop and we'll talk more. If you have questions on keys, please come back tomorrow. The keys and integrity constraints are related. Okay, certain things that we talked today. For example, primary key has to be unique. There cannot be a table with two primary keys. A table cannot have two primary key. That's a constraint. The primary key of a table cannot be null. I cannot say go to a table, fetch me the marks of a student who is null. It doesn't have a meaning. Okay, it doesn't give me a meaning. So primary key cannot be null. So things like that, these are called constraints. Okay, foreign key is a constraint. I cannot have a foreign key without it being a primary key in another table. Okay, I explained that in the other day. I cannot store marks of, for example, somebody, others. I cannot store the marks of others without storing his primary information like his number, name, date of birth, everything. So first the parent table has to have the records, then only the child table can take the records. Make sense? All right, with that, I'm going to stop for today. I'm open to take questions if he has anything. But otherwise, we are good. Thank you guys for your time. But I'm going to stay here for some more time. Feel free for any discussion related to the DBMS, outside the DBMS, any review, comments, feedback, I'm happy to take.